Before we get into some specific problems for decimals and percentages, let me give you a brief introduction, or for most of you it's going to be a review of what we should be careful of when dealing with decimals and percentages, and also to realize the relationship between those two entities. Let's look at decimals first, and I know this is pretty basic for most people. Two things you need to remember about decimals. When you are adding or subtracting decimals, make sure that you line up the decimals. Now let's put 48.684, and let's say we've got 3.2. Okay, you don't want to put that 3.2 over here, obviously. So what you want to do is make sure that you line up the decimals. So you'd put the point here, and the 3 goes here, and the 2 goes there. I know this is pretty basic, but you might be surprised how many people screw that up. So we'll talk about it a little bit here. So then we go ahead and we just add as usual, and we put the decimal where it falls and do the addition. So that's addition. Now on multiplication, you've got a slightly different thing. You don't have to worry about lining up your decimals when you're doing multiplication, but you do have to count the number of decimal places when you get down to the final answer. So let's take 3.6 times 4.872. Okay, obviously the decimals aren't lined up. We don't care. 6 times 2 is 12. Carrier 1, 42, 43. Carrier 4, 48 and 4 is 52. And carrier 5, 24 and 5 is 29. And we go 3 times 2 is 6. 3 times 7 is 21. Carrier 2, 26. Carrier 2, 14. Now we come down to the final thing here. 9, 3, 15, carrier 1, 7, 1. Now, here's where you have to be careful. Where do you put the decimal? Well, you count how many decimal places you had there. 1, 2, 3, 4. So you'd go over 1, 2, 3, 4. And there would be your answer, 17.5392. So that's what I want you to remember about decimals per se. The other thing is, when we're talking about percentages, and if you've been looking through the Princeton Review, you probably have noticed in the practice examinations that they've given you, there are a large number of percentage problems. And tonight, when we look at this, we're going to pick out some of those percentage problems. We're not going to cover all of them, but hopefully it'll be enough of a sampling that you'll get a good idea what it is you need to know about percentages. But since we've been talking about decimals, let's see what the relationship is between a decimal and a percentage. A percentage is a way of expressing hundredths. So if I've got 48 hundredths, I can write that as 48%. I can also write 48 hundredths as 0.48. So you see a triad here. You see it written as a percentage where it's a whole number in front of a percent sign. And you see a decimal to 2 places. And you see it written as a fraction. Now what you're going to see on the SAT is they're going to mix these. There's going to be times when you have to turn a percentage into a fraction, or a percentage into a decimal, or a decimal into a percentage. And so you need to understand that relationship. So basically that's all I need to tell you about decimals and percentages as we get ready to look at some specific problems that utilize these concepts. In this video segment, we're going to be talking about two things that are kind of related. We're going to be talking about decimals, and we're going to be talking about percentages. Now, if you've had a chance to look through some of the practice exams in the Princeton Review book, you probably were surprised at how many questions are based on percentages. Now, the relationship between percentages and decimals is pretty obvious. And we will be doing some problems in the beginning where we're going to convert back and forth, convert from a decimal to a percentage and from a percentage to a decimal. And you're going to have to understand that process when you do the various problems that you'll see on the SAT. So let's take a look now at some typical problems and how we go about solving them. Okay, now let's take a look at some problems that are straight out of the Princeton Review practice exams. We'll start out with an easy one. This is a number 5, so it's perceived as being easy. And you probably won't find many of this easy, but let's take advantage of it. We'll kind of ease into some of the more difficult ones. Cindy has a collection of 80 records. Now, 40% of her records are jazz records, and the rest are blues records. How many blues records does she have? Now, probably if there's a Joe Boggs here, he would just see two numbers and he'd say, okay, I'm going to change 40 to 0.40, multiply it times 80, and that'd be my answer. And he'd be down here circling 32A, and that's not the right answer, obviously. The fastest way to get that, and there are several ways to find the answer, but the fastest way, if 40% of them are jazz records, that means the other 60% have to be the blues records. So it's one step, just multiplying 60% times the total number of records. And 60% is the same as 0.60, or just plain 0.6. So we're going to take 0.6 times 80, and we get 48, so your answer is D. Okay, let's take a look now at another percentage problem, and it's also a decimal problem. The only way they can make these things difficult is to kind of twist your mind a little bit, and this is no exception. They're giving you a decimal form of or a decimal percentage instead of a whole percentage. That's a little bit of a twist. And they've got a bunch of variables thrown in here. So let's decipher what they've got. Let's read it first. If 0.1% of M is equal to 10% of N, then M is what percent of 10N? Okay, now just looking at this, one of the ways we want to find it is get it down to either 10N or find out what N is and multiply by 10. That's my strategy. I want to write this, I'm going to deal with fractions rather than percentages because it'll make it a little easier for us. So how do I write 0.1% as a fraction? Well, it turns out that 0.1% is the same as 1,000th, okay? And we're multiplying that times M. So we can just go ahead and make that M over 1,000. And it's equal to 10% of N. Now what's 10%? 10% as a fraction is 10 over 100. So that's the same as 10N over 100. See what I've done here? I've multiplied 10 over 100, which is 10%, times N. Now, once we set it up this way, we can cross multiply. And we get 100M equals 10,000 N. Now, what we want to end up with is 10N. So what do I have to divide this side by in order to just have 10N over here? I know I need to divide this side by 1,000 because I've got 3 zeros I've got to get rid of. So I'm going to just put 1,000 under here and mark those zeros out over here. But I've got to also divide this side by 1,000. And we want to know what percent, the m is what percent of 10n. So we want to find out what hundredths of m is this 10n. So we want to get this down to just plain hundredths. Well, if I'm going to get it down to hundredths, I need to knock off 1 0. So I divide top and bottom by 0. And I get 10 hundredths, which is the same as 10% or C. So you see here, it's very important that you understand how to go back and forth between fractions, decimals, and percentages. Okay, let's take a look at another percentage problem. As I said before, the only way they can make these difficult, and they will make them difficult on the SAT, is to put a brain twister in here. And the twist they put here, they first say for positive integer x, and you're thinking, okay, positive integers. What are they talking about here? 10% of x percent of 1,000 is equal to which of the following? So here you not only have this positive integer thing going on, they asking you a percent of a percent. So let's break it down and see, we'll untwist it, in other words, okay? Let's break down this part of it first, 10%. Well, how do you write 10%? Let's write it as a fraction. You can write it several ways, but it's probably going to be easier to deal with it as a fraction. That's 10 hundredths, right? And then we want to take that 10 hundredths times x percent. Well, what's x percent? Well, x percent is x over 100. Okay, so we got this part now. And now we're taking that percent times 1,000. Okay, so now all we have to do is find out what we end up with when we get rid of all these zeros and everything. Now, there's several ways I could simplify this. I could just mark a 0 off here and a 0 off there. And I end up with 1,000 x over 10 times 100, which is the same as 1,000. And right away you should see how you can cancel here. And when you cancel, what do you end up with? You end up with just plain old x, and that is our answer.